Well, everybody, I'm back at trying to take some test cuts with this setup here. The last video I posted on the Vernon Lathe showed where a couple of times the whole lathe stalled because it couldn't handle the cut, and a couple of my viewers commented about that. They felt that might be something going on, that this lathe should be able to, a lathe this size should be able to handle a cut that heavy, and there was some mention about the horsepower of the motor. I honestly don't remember what the horsepower is of that motor. I know I had that information. It's on the back side up against the wall right now, so I can't see it. I also know it's a 220 volt or 120 volt motor. I've only got it wired for 120. Eventually, when I get everything situated more permanently, I will wire that for 220 more than likely. But the truth of the matter is, when it stalled, what was slipping was the big wide leather belt there. So I just tightened up that belt some more. I don't know what the proper tightness is on that belt, so I've got that pretty darn tight right now. If I snap that belt, no big loss, because it's a pretty old belt, and it might even have some, it might, for all I know, it might even be contaminated with oil. I'm more concerned about whether or not, by having the belt too tight, whether or not I'd be putting any undue strain on my my bearings, spindle bearing. But anyways, so I get that all tight. I just set this up for a 25 thousandths cut, so I don't quite, let's see what the feed is. Alright, as far as feed goes, I've got the intermediate transmission here in position 1. I've got my feed lever right in the middle, so that's going to be 48. That's threads per inch, and it says right down here, it says the feed is 4 times threads per inch. So 48 times 4, that's 196, right? No, that's 200 minus 8. It's 192. All right, so my feed is 192 theoretically. RPMs. What did I do with that paper? I wrote down all the RPM settings. I had it around here somewhere. Well, let's just see what we got. All right, just oiled up my spindle bearings. Talk about chatter. The whole floor was shaking. try and slow it down. Alright, so obviously I can't do what I was doing there, because when it was rumbling and shaking the whole floor, the concrete slab that I was standing on, that vibration was translating to a horrible finish. So I just looked at this tip on this carbide cutter that's in here, and it looks like it may be damaged. Now, question is, did I damage it with my experimentation? I mean, that was a used cutting bit when I got it. The other thing that perplexes me is I just was looking at how to change it, and I don't know if I'm seeing things, but I think there's actually a second cutter underneath this. So that kind of blows my mind. Alright, so I think you're supposed to loosen this Allen screw in the bottom here, and that's supposed to allow this cutter to be removed. It's like it's like a cam action. I see. Alright, so that lets me take that cutter right off. So what the hell is this? Alright, that's not another cutter, that's some kind of a spacer. Okay. I guess that's supposed to be there. Alright. So the whole front edge of this cutter over here is rubbed off. This is rubbed off completely. And that actually looks like that just happened. So it almost looks like I've got the wrong angle here or something. Either that, or I broke the tip, and once I broke the tip, then it started rubbing. Alright, so let me, I guess it's possible. This might be a cutter that has zero rake or negative rake, and that might be my problem. That's the thing, with this having no discernible markings on it, I have no idea what this is. Wow, this whole side of the cutter right here, which I didn't even notice it until I looked at it under magnification, is all like chipped away right here, almost as if like this was being used on the side to cut something. Alright, well that's junk. Well, I think I just answered my own question. I just found another one of these cutters, looked at it more closely and realized this must be zero degree rake, because it looks like this cutter is identical from each side, almost as if it's made to be flipped over. And is it possible that you got 1, 2, 3, 4, 5, 6 cutting edges on this? And that looks the same. There's another one. We just flipped it over so that one of the better cutting edges is facing up. Let's see what happens. Oh, as far as the speed of the lathe goes, I just checked it, and I've got it in the lowest setting, the lowest speed setting I can set it to without putting it in back gear. So I'm going to keep the speed the same as it was. We'll just see how it acts now with this new cutting tip in there. And I guess first I'll just take some light cuts to try and do some cleanup on this. That's a lot better. That's interesting. The auto stop didn't kick in that time. This is going to be a 50 thousandths cut, but I want to get some oil. chips. It appears you shouldn't try using a broken cutting tip. So you can see these some of these are actually from my other cuts the other day, but they range in straw colored to just downright bluish gray. Which, if I understand what Dave was trying to tell me, that's what I'm striving for with a carbide cutter, that I'm transferring the heat to the chip, that the heat from the cutting process is being taken away by the chip. And I remember an evening instructor I had when I took a machine shop course years ago. I don't remember a lot of things about that, but I remember it was all high-speed steel tooling. And I remember one night he came in and he brought in a carbide cutter, an end mill, from work. And we threw it in one of the old Bridgeports there, and we cranked that speed up really high compared to what it was, and the chips were flying and they were coming out, and the chips were really hot. And I think he had mentioned at that point that what was happening there was that the heat of the cutting process was actually being was going away with the chips, which was what you really wanted to be happening in that situation, if that makes sense. But that finish is much better. Still a little bit of chatter in there, but it's not as bad as when it went. Well, obviously, I think the key here was we had a broken cutter. I don't have any time. I want to come back down here when I have some more time and do some more experimental cuts just for the heck of it. Oh, what the hell. Let me try and take a 50 thousandths cut before we go up. How about 75 thousandths? Starts out cutting 75 thousandths, and then the chatter starts to get really bad. The vibration gets really severe. I think the other thing David noticed was that I went through all the trouble of squaring up this tool post. He was talking about the cutting force needing to be more in the direction going towards the chuck instead of the center line of the spindle, or the axis here. And that's what I've got right now. The end of the holder is turned that way a little bit. But what's happening is when I'm turning up to this shoulder, the side of the cutter is rubbing really badly on the... what's happening is this side of the cutter hits the shoulder before I get to finishing my cut. So I think I should loosen my tool post and turn it a little bit. Can't tell, but I may have broken that cutter again. Yeah, I just pulled that out and looked at it on the magnification, and I damaged the tip again. It's not broken, it's just damaged. So Greg, another one of my frequent commenters, he told me what to look for in a turning tool. I'm just gonna still though keep playing around with what I've got, just because I have it, you know. I gotta believe somewhere in all of these cutters that I have that there's gotta be some combination here that'll work well for turning. But I do want to also turn this whole block, try it again that way. Alright, I'm going to loosen up the tool post and change the angle a little bit, play with it a little bit more tonight. Boy, you know, I really need to get a dedicated wrench for this. This is an 1.5 inch nut. I don't have an open-end 1.5 inch wrench. I thought I did, but apparently I only go up to 1.25 inches. I'm really wishing I had bought, well, a couple months back when I went down to Rhode Island and I bought a whole bunch of stuff, machinist stuff off of a guy. One of the things that I passed on that he had was he had a really big adjustable wrench, one of the largest ones I've ever seen. It would have been the largest one I own, and it would have been perfect for this job. I think I'll just probably go to the flea market or the used tool store and spy me a used 1.5 inch wrench. You know, it doesn't even need to be anything fancy, even a junky old Chinese one or something, or India. So I don't know. Yeah, do I want to go with that? I guess I could even go at an angle that much. Well, what the hell, let's see what happens. Alright, so here's a shot right from behind, standing at the apron. So now you can see with the tool post turned, that in conjunction with a little bit of an angle that's given on the cutter right here, now the actual cutting edge is almost pointing at it an angle like this. So that now this side edge right here, when I come up against this shoulder, this side edge isn't all going to be rubbing like crazy. That takes care of that. I got one more little bit of business, and that's to flip this around to a new cutting edge, because I damaged that side again going up against this, going hard up against this shoulder. Oh, that's nice and smooth. That's really nice. chip just went down the front of my shirt. It was burning me. But yeah, I think I'm getting somewhere. Nice and smooth. It's cutting nice. Alright, so I like this angle that I turned this at. That also allowed me to face the end, which I hadn't done yet. That came out nice. No dimple, by the way. So it looks like I'm dead on as far as my height goes. Yeah, this is kind of cool. Kind of cool. Now, if I could just fix the gear train on this lathe so it doesn't sound like a God, I don't even know what to describe it as. It just sounds, it's a jalopy. That's it sounds like a jalopy. Well, one of the new noises, the tick 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 noise, which you guys may have picked up and not noticed before, that's since I tightened the belt, I noticed that I'm now getting this well, let me just show you the metal lacing on the belt. When it comes around, it's hitting the belt guard somewhere. You can literally see the belt guard. Well, I feel kind of silly. I had this bracket right here going on. I had it on the front here. So in other words, this is an angle bracket right here. And all I did was, since I knew I needed to move this back that way a little bit, I unscrewed it, put it on the back side of this, tightened it up, and now it's actually much more rigid this way, because now it's clearly whoever made this bracket meant for it to go right over the top there and have sit on this top edge. And so now this is actually supported better and the alignment's a lot better, and so now it's not the metal lacing on that belt when it comes around isn't hitting it. So no more annoying tick 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 tick, so that takes care of that. Of course, we still have the the other noise that's nerve-wracking. I think what I'm going to do is I'm going to engage the back gear and see if I can't get a better appreciation for where that noise is coming from. Maybe there's some more filing I can do on some teeth. Well, actually, when I go really slow, you don't even hear any of that noise. It actually sounds like it's not even engaged, but it is. I just engaged it. So, I gotta go faster than that. Now, it's kind of difficult to recreate that gear train noise with it in back gear. This is the top speed in back gear, and it actually doesn't sound bad. It's a very slight rumble. Now let's contrast that to taking it out of back gear, the lowest speed out of back gear. You can hear that. You like that imitation? Well, that's a little better. I just pushed in that side gear. This is the immediate gear. Whoops. Oh, that's right. Pushing it all the way in is neutral. So I was actually pushing it more towards neutral, and that's what made it quieter. When it's out here, oh, I think I'm figuring something out. If I push it in part way like this, that's what quiets it down a lot. So what's happening is when I push it so that it's just riding on the back side of this gear, not engaging the front teeth of this gear, that's when it gets real quiet. I'm also noticing that when this is out here, there's quite a bit of play on that shaft. That shaft's worn.